In today's module, our today's module is about networking in Java. In this module, at the end of this module, we should be able to create a client server application using Java. Fine. So, let us begin this by understanding what is networking. So, what is networking about? Yes, networking is about having communication between processes working on which may be on different machines. Fine. Okay. So, what is necessary? What is required for this networking? What is the requirement to achieve this kind of networking, to have communication between two processes? Yes, this communication is going to be between processes which are running on different machines. So, first part will be to have a mechanism of having some kind of a connection, physical connection between the machines. And so, for that, yes, what is necessary? What is required to have that physical networking? We will need some hardware. So, the first layer which is to be achieved for networking would be a physical layer, which mainly consists of the hardware. One of the important part of the hardware would be is a network interface card. What is the role of a network interface card? The role of network interface card is to have yes, what is the role of a network interface card? The network interface card, the role of network interface card is to convert the data into signals which can be conveyed on some media, and whatever signals are coming from media has to be converted back to the data. So, fine, this is about conversion from data to signals and signals to data according to the media for which the network interface card is designed. You may have a wireless interface connectivity, you may have a UTP connectivity. So, whatever the media may be, but we need an appropriate network interface card, and the role of the network interface card is to convert from signals coming from the media into from media to the data and data back to signals. Fine. Okay. So, yes, this is what the network interface card does. Now, this role of network interface card, yes, where is this code which can do the conversion of signals to data and data to signals? All this is going to be within the ROM of the network interface card. Okay. The ROM, so this part, this program which is in the ROM of the network interface card, or rather which is in the firmware here, is what we call as the data link layer. Again, another important thing for networking would be, in any communication rather, is we always need the communicating the entities involved in communication. Here, the entities at this layer, data link layer, are the network interface cards. So, they need, each such entity needs a unique identification. For the purpose of identification, each of the network interface cards has a MAC address. Yes, what is a MAC address? It is a unique identity available for all the network interface cards. A MAC address is made up of 48 bit. We have 48 bits for the MAC address, but how do we manage uniqueness? Fine, these the network interface cards would be manufactured by so many different manufacturers. So, what has been done for this is, the 48 bits of the MAC address had been divided into two parts. First part is the 24 bits which is used for identifying the manufacturer. So, each manufacturer is allocated a 24 bit within which he needs to ensure that all the equipments which he any networking equipment or any network interface card which he manufactures, he uses the next 24 bits to make it unique. So, that way we achieve uniqueness across all network MAC addresses across all network interface cards. Fine. So, we have data link, we have the data link layer. the network interface card working for us. But yes, what's the purpose of networking? It's about communication between processes. It's not communication between network interface cards. It's just a media which will help us. But yes, we need communication between networking. From the user's perspective, a user doesn't identify network interface card, it's just another piece of hardware for him. What is more useful, what is identifiable by a user here would be the host. Fine, your machine may go wrong, something goes wrong with the network interface card, you will change it, you will have a different MAC address. No. So, our identification from the point of view of communication between processes, we do not need identification of the network interface card, the MAC identification. Rather, we would work using the identification which is from the host, something which identifies the host machine. Okay? And therefore, we have the next layer, which is the networking layer. In the networking layer, we have a mechanism of identifying hosts which will participate in a network. Now, here comes a software. This role is to be there, this role of having some identification available for the machines in a network would be done by operating system. Fine. So, this is part of the software. Another thing, for the network layer, it's not on, we have, since it's a software, there are various schemes which can be there for making identification related to hosts. Fine. So, one such protocol which is most commonly being used for identification of hosts in networking layer is the IP protocol. This is most commonly used, and so again here for IP protocol, yes, our operating system or each host is identified using a unique IP address which has to be unique within its network. Okay. So, here again we have various versions of IP protocol. IP address is going to be a numeric value which is used for identification. We got various versions of the IP protocol. Fine. So, most commonly used IP protocol is IP version 4. We do have another one which is IP version 6. We do not have IP version 5. Okay. In case of IP version 4, or shortly we call it as IPv4, we use 32 bits for IP address, whereas in case of IP version 6 there are 128 bits, but whatever it may be. Fine. How IP is used again. Now, in case of MAC, we had division of MAC into two parts, identify manufacturer, and then we have a serial number assigned by the manufacturer. Similarly, here in case of IP address also, our IP address is also divided into two parts. We have initial, the most significant bits of our IP address being divided into being used for identification of a network, and then the rest of the bits would be used for identifying a host within the network. The host within the network should be unique. Fine. So, all those hosts which have the same network address can communicate with one another. So, all hosts which are part of the same network will have the common bits for the networking part. Again, how many bits are used for networking and how many bits for host within a network is something which can be decided by a network administrator. Okay. So, when a network administrator sets up his networking, his machines or hosts for networking, based on his requirement, whether he would like to have smaller networks with more number of hosts in each network, or he would like to have large number of networks which are small in size. So, each network having less number of hosts. So, based on his requirement, he can divide the bits available, the total number of bits available to him into two parts. For example, if we are using IP version 4 and maybe we have got 30, in IP version 4 we got total 32 bits, a network administrator can then decide that he would like to use maybe first 10 bits for network and rest of the 22 bits for identifying the host within the network. Fine. It is not necessary he has to be using some multiple of 8 bits, though there are certain standards which are used, but they are not necessary. It is yes, if you are following on the internet, if you are following the internet, we do have classes of IP addresses. So, in those cases, yes, we have multiples of 8 bits only. So, like 8 we have class A IP addresses where we use only initial 8 bits for the network and 24 bits for the host part, or we have class B where we may be using 16 bits equal, that is 16 bits for network part and 16 bits for host within the network, or it could be the class C where we are using 24 bits for network and 8 bits for host within the network. Now, whatever is the the network administrator, he can decide whatever number of bits he wants. So, now how do you set up your host for networking initially? So, if a network administrator has to set up a host for networking, one of the things he will be doing is definitely he has to be assigning an IP address to it, fine, which is nothing but a 32-bit value. If we are following IPv4, I will be assuming IP version 4 here, okay, in our discussion here. So, so if he is following IP version 4 and if he can decide. So, now so for one part is, yes, he is specifying an 32-bit IP address, but within this IP address he again needs to indicate how many bits in this IP address, 32 bits here in our case here, how many bits he is using for networking. Now, how does he indicate this? He can indicate the number of bits used for networking by also specifying a subnet mask. A subnet mask is again for IP version 4 would again be a 32-bit value. A subnet mask is specified is nothing but a 32-bit where we have initial most significant bits as ones followed by all zeros. The initial ones, the number of initial 1 bits indicate the number of bits which would be used from the IP address as the network address, and rest of the bits are used for host within the network. Again, in any network, the host part, the host bits, we have two values in the host part where we sort all bits of host as zeros and all bits of host as ones to have been reserved. All bits zeros here is reserved to indicate the network address, and all bits 1 for the host part indicate a broadcast address. Fine. So, this is like this is about IP address and how to set up a machine for networking. The minimum requirement would be to set up some IP address, indicate 32 bits, and another subnet mask to indicate how many bits identify the network. Once this has been done, another point here, when we mention about IP addresses, talking about 32 bits, that may be tedious, someone remembering a whole 32-bit value. So, yes, what we commonly follow for specifying an IP address, it is a notation. We use a decimal dotted notation. In the decimal dotted notation for IP addresses, we divide our 32 bits into 4 bytes and we write the decimal value of each byte separated by a dot. Fine. For example, you might think of some IP address which is made up of 4 bytes. Now, each byte, the range would be between 0 and 255. Okay. A common IP address which we may find and which is used mainly for intranet address would be something like this. We have 192.168.1.75 or something. Yes. So, here when we are saying 192.168.1.75, yes, the 192 is the first byte of my 4-byte IP address, 168 second byte, third byte is 1 and fourth byte is 75. So, that way we get full 32-bit IP address. And here suppose if we are interested in specifying that yes, we would like to use only 24 bits for the network, fine. For the network you will specify a subnet mask. Again in subnet mask also we use a decimal dotted notation. So there again we can indicate 24 bits for networking by specifying 255.255.255 for the first 3 bytes, indicating all ones. So 24 ones, then dot 0. So 255, 255, 255, 0, that would be the subnet mask in this case. So that way we can set up a machine. The minimum requirement for any machine to be set up for networking using the IP protocol would be to specify an IP address and a subnet mask, fine. So that is a minimum requirement we will have, fine. So this is part of the network layer, but anyway we are talking about our requirement about how do we have communication between processes. So moving further, fine, okay, what have we achieved with network layer? We have achieved unique identification of hosts. All hosts in our network have been identified. Hosts are identified, but communication is not between hosts. Hosts are just piece of hardware. What we want is communication between some process. Oh, there are so many number of processes working on a host. So any process on one machine would like to communicate with a process on another machine. So it's not sufficient just to use an IP address. IP address is identifying only our host here. In order to have communication between two processes, okay, let's see, let's take an analogy from a real world, fine. As an analogy, let's see, like let's consider a process. Process is something which is working. So let's consider a process from the real world. Let's consider a town as being a host machine. The persons in the town are like the processes who are working on the machine. Now it's about some person in this town wants to talk to another person in a different town. How does he achieve this? So what are the common ways of communication which we normally use here? Yes, we have two common ways of communication. What is it? One, we use a telephone, the most common one, right? Oh, we are used to that. Oh, immediate, just make a call and then talk to some other person. And what's the other one? Oh, you don't want to have him disturbed, or maybe whatever he is doing. So another way is maybe you want to send a message to him. So you won't just send a message and it would be received by him. But when you are sending a message, you don't really know when he is receiving or he is not receiving, when he has received it or not, right? So yes, similar to these two kind of communication, on top of the IP protocol which we have for the network layer, we have on top of network layer, the next layer is the transport layer, whose main job is to achieve some kind of a mechanism by which data or bytes can be exchanged between processes. Okay. So yes, similar to what we found in real world, here again there are two common protocols which are used for communication between two processes. One of the protocols which works on top of IP and most commonly used is the TCP protocol. So we have TCP running on top of IP, or we may have UDP, fine, which is running on top of IP. Both require IP. Okay. Now in case of TCP and UDP, let's make a small comparison here. It's similar, that TCP here is similar to the telephone based communication. In telephone communication, what do we get? We get a continuous stream of bytes. In telephone communication, we get a continuous stream of voice. Instead of voice, here it is going to be bytes. We have a stream based communication. TCP is a stream based communication, whereas UDP is a packet based communication. In UDP, you prepare a packet and send it and forget it. you would not know when it has reached, when it has not reached. Only when he replies back, then you will know, oh, he had probably got it. Fine. So, that way we have got TCP and UDP, two different protocols working for us. Okay. So, which are common choices here. We do have other protocols also which are working at transport layer, but these are the two most commonly used ones. One is stream based, the other is packet based. Fine. Okay. So, once we have a communication like this, which is a stream based and packet based communication, and then let us see, does it suffice to have a connection over a telephone in order to achieve communication? Is it sufficient for us? Okay. Is it sufficient to just, okay, if I make a call to someone and I've got connected, he's received the call, he's picked up the call phone on the other side. Do we get communication? Do we really have communication? Is communication just about exchanging some voice? No. Just think, you make a call to someone in China and start speaking in Hindi, what would happen? Okay. From our, what the telephone has achieved for us is, it has achieved the means of sending our voice across. The voice is traveling, but there is no meaningful communication. Fine. Just exchanging voice is not communication. Fine. Similar to that, in yes, in transport layer, we have a mechanism of being able to send bytes. A process can send bytes from one machine to the other machine, from one process to the other process. Fine. But is that sufficient for communication? No. What do we need for communication? This exchange of bytes should be meaningful. Fine. They should speak a common language. There has to be some pre-decided rules according to which the communication should work. Fine. And that is where we have the application layer. So, application layer, yes. So, that way we need all these layers. Now, another important thing which we have, let us go back to the transport layer. Fine. The important thing at the transport layer would be, yes, how does the transport layer work? So, if we go back to that same analogy where we said, yes, our we will concentrate more on the TCP protocol here. So, our analogy was TCP is similar to a phone connection. Now, we considered each in that phone analogy, we had each town is similar to a host and the persons in the town are the processes. So, similarly, if we consider this, so what we have at the network layer, we were able to identify each host. Host is like a town. Okay. So, now if we think in terms of phone, we have a code for each town, like we have the STD code available for each town, fine, for communication purpose. And then what do we need ultimately? Can I talk to someone because I know the STD code, or can I talk to just any person there in the other town? Oh, I can only communicate to a person who has a phone. If he does not have a phone, no, I can't talk to him. I need to have a phone. See, both sides, a phone is needed. And something important about phone, oh, they have a number. So, yes, that phone number here is a resource. So, similar to the phone number which we use in our real life communication, in the TCP IP communication, the TCP layer requires a port number, that is like a phone number. So, you can think of the STD code is something similar to a IP address, and then IP address, okay, and then we have the phone number similar to that. What we have here is a port number. So, in order to have communication, what will be needed? A person needs to have a phone. Another important thing, let us also look at another aspect in the communication which we have. We would always have a communication which is between a client and a server. We think about a client and server communication. So, if you think of a client server communication, again going back to the real world, how do we have this client server communication? A client server communication will be when we have, okay, what is a server? So, if you want to think of a server, just think, if you have some emergency, what do? Oh, you dial 108. What is that 108? It's a service, fine. And then who initiates the communication here? The one who needs the service. That one who needs the service is the client. The one who is giving the service on the other side is the server. Now, what is required for a client in order to avail the service? The client must know the fine. In real world, the client must be knowing the phone number where this service, where can I avail this service? Okay. So, same way in our TCP/IP communication, we have server processes and we have client processes. A server process, communication with a server process, if a client wants to communicate with a server, the client must know the port number on which the server is listening. Yes, we talk about server listening on a port, fine. Okay. Now, this server listening on a port is similar to, again, something about how services are given in real life also. I happen to have seen some in a telephone exchange how service is given for one of the services which was very old. In the old days, there used to be service for trunk calls that was on 180. Now, how they used to work? So, if you go into that place from where they were giving the service, it used to be a room where we had a lot of operators in a corner, and we would have we had a board in one corner of the room where there were a lot of lamps available. When any client would connect, when any client makes connection to this service, a lamp would glow, and when a lamp glows, one of the operators says, okay, I'll handle this client, and he starts the communication. So, communication, as far as the client part is concerned, the client simply makes a connection, makes a call, it comes on the board, and from the board it is an operator who uses again another phone instrument from which the communication is done. And then, okay, while this client is being handled, if another client calls, okay, another lamp would glow and another operator would say, okay, let me handle the second client. So, we have simultaneous handling of multiple clients by a server, fine. A server should be, we have multiple clients being serviced, fine, in our real world also. Similar to that, here also in our TCP/IP communication, we have two kinds of processes, a server process which should be capable of handling multiple clients simultaneously, fine. And on the client side, yes, client just makes connection to, it is a client who will be always initiating connection to the server. Okay. So, we talked a lot about how what is networking, how it is done. We have seen the requirements of networking, we have seen the physical layer, we have seen the requirement in terms of hardware. Then we had seen, okay, one of the pieces of hardware, that was the data link layer doing the conversion. Then we have seen that identification of hosts, which requires for which we may use IP protocol. So, we have an IP address assigned to the host, and then we have processes. Now, when we come to the transport layer, where we have the processes and each, so here we need to talk about two kinds of processes, a server process and a client process. And here, of course, it is a server process which is playing an important role, because that is the one, it's only the client has only got to be able to connect to a server. So, it is a server process which would always be the one which would be starting first. Okay. Let us see how the various what are the aspects of communication, or Rather, I think we have talked a lot about networking in terms of the requirements here, but then let's look at how Java fits in here, what Java provides us to achieve all this. Okay. So, as far as, so now talking about the things, requirements in Java, find what Java gives us to achieve this kind of TCP/IP communication. Okay. So, to achieve this TCP/IP communication, the two common classes available in Java, one of them is the class called server socket and the other class is the socket class. Okay. Taking that analogy from the real world, the server socket here is like the board and which is used for giving which is used by someone who is giving a service on which a call lands, right. So, similar to that, what we have here is a class called server socket. The object of a server socket is the one where calls can be received or connection can be received rather, and what is used by the client, and of course, it is also used on the server side, is the socket, object of the socket class. So, let us see how what are the steps required to establish a communication between a client and a server. First part we will have to look at is the server side. Okay. So, let us see this class called server socket. Okay. The server socket class provides us a constructor where it can take an integer as a parameter indicating a port number. So, yes, a server process when it wants to start has to start on a specific port number. So, it is like this, that port number, the server process wants to reserve a port for itself using. So, what a server process does in case it is a Java application you are writing, if you are writing a Java application for server side, that application would first have to create an object of server socket in which he indicates the port number. So, calling constructor of server socket creates an object of server socket. This constructor of server socket would only be successful if the port specified by that process, the port specified in the constructor has not been used by anyone and is not a privileged port. Yes, we do have privileged ports. We have port numbers which range from 1 to 65535. A server, we have out of these 1 to 65535, the port numbers from 1 to 1023 are the privileged ports, in the sense that yes, it is only the processes which have administrative privileges, they can only reserve this port, they can find. So, in case of some Java application, if this application is not being run as a privileged application, in case of Linux for example, if it is not being run as a root, then you would not be able to get, you would not be able to use port number less than 1024. Okay. This is similar to, you have your phone numbers also, you have those services normally coming on phone numbers which are less than 1k, right, 3-digit numbers. So, it is similar to that. Here also these are privileged numbers less than 1k of binary. So, 1024 here. So, anything less than 1k is a privileged port, and this normally requires that it is only the root user on a Linux machine, it would be a root user who can only be, who is allowed to use such port. So, in case a Java application is a normal Java application, fine, not run as a root user, it would not be able to use this port, fine. So, yes, the constructor of server socket is successful if this port number is not being used by anyone else, fine, and it is not a privileged port, okay, or he has the privileges, rather we can say, okay, if he has the privileges to use that port, fine. So, you have the requirement and it should be in the range of 1 to 65535. Okay. So, or this constructor would, okay, what are the reasons for the failure of this constructor? Another reason was, if this port is not used by any other process. So, it is like the phone number, oh, no one else has the same phone number, Okay. So, it is like we can't have two persons with the same port number, each person is like a process here. So, we have a Java process, the Java process takes up a port, and so using the constructor of server socket, the application, the Java application is doing, server side Java application is able to reserve a port for itself, on which it then starts listening for client connections. Yes, it is now capable of listening for client connections. Fine. It is like, so creating, if you are successfully able to create an object of server socket, it is just like as if you have set up a board for yourself with that on which can listen on a particular number. Okay. Now, this board, on this board we need some operators who would start listening, who would actually give some service, but yes, they do not start servicing, they do not get a connection unless there is a client on the other side. So, initiation of the connection would be done by a client. There is no connection here. Only thing, yes, he is ready for giving a service. That is what the constructor of server socket does. But another thing which the servers on the server side, what needs to be done after creating a server socket, after reserving a port for itself, is it should be able to, it should be ready if someone gives, if some client is making a connection, I should be ready to handle that connection. Fine. I should be able to have someone to start giving service to him. So, for that, yes, what we have is we have a method in the server socket class. So, on the object of server socket created in our step 1, okay, which is calling, step 1 is about calling the constructor. In the step 2, on the server side, the server process just calls a method called accept on the server socket. When the accept method is called, accept method is a blocking method. It would wait for a connection from the client. When the client would connect, it is just blocking, so it is not doing anything till the client connects. Okay. And once the client connects, it returns an object of socket class. Yes, we will look at it later. Let us see, because here what is important, the second step is blocked. It is not that it is going to return a socket once I call the socket accept method. It is still waiting and not returning a socket unless a client connects, right. So, at this point on step 2 it is blocked on waiting for a client to connect. So, yes, let us look at the other side now. For the other side, what we have? A client wants to make a connection. How does a client make a connection? What should a client know in order to make a connection? The client should be able to know on which machine is this process to which I want to connect, and on what port number is that server listening. Okay. So, yes, we have the socket class providing us with a constructor which takes two parameters. We have in the constructor the first parameter where we can specify the host, and second parameter is an integer value where we can specify a port number. The host is used for identifying the machine and port number to identify the server process to which you would like to make a connection. So, on the client side, we have the first step here is to just call the constructor of socket. So, what happens when a constructor of socket is called on the client side? Yes, at this moment, this constructor of client, the constructor of socket on the client machine is only going to be successful if we have, if we have a connection from the client machine to the server machine available to us. Fine, it should be able to connect. Yes, there it should be able to also on the server machine. There has to be someone, there has to be a server process who has been listening on the specified port number. So, if this is already done because of the first two steps on the server side, this constructor of socket should normally be successful. Okay. So, what is happening at this time? What is happening here? Yes, on the client machine we have a socket getting created because of the constructor, but look at the other side also. At this moment on the server side, what is happening? We had the second step on the server, which was a blocking method, it was blocked waiting for a connection from the client, and here is a connection from the client. So, what is happening? What does that accept method do? It is blocking for client, but when a client connects, what does it do? It returns a socket object. So, we got two sockets getting created simultaneously, one for the client machine, which is because of the constructor, he is called the constructor to make a connection, and other one is the accept method on the server side. These two sockets are connected to each other. How are they connected? Oh, these are, what kind of connection is it? It is a TCP IP connection, which is a stream based connection. So, what do we have? We have the two sockets connected on a stream based connection, and what does a socket contain for providing us a stream based connection? Each socket has two important components. A socket, any connected socket has a input stream and output stream. So, we have our socket on the server side, on a client side having an input stream, output stream. We have our socket on the server side also having its own input stream and output stream. And how do we say they are connected? There is an important thing here. The two streams which we have a stream, we have an input stream on the server, we have an input stream on the client, and here we have an input stream on the server, we have an output stream on the server. This is what is connected to each other. We have the input stream of each socket, the two connected socket, the input stream of one is always connected to the output stream on the other side. Okay. It means that yes, what do we do with the input stream and output stream? What are they used for? How do we use them? We use an output stream for writing, right. So, we give bytes to an output stream using the write method. Yes. So, what happens here? If you write to an output stream of a socket which is connected to another socket, whatever you write on the output stream of the socket is available for read on the input stream of the other opposite socket. When I say opposite socket, I am talking about the connected socket. So, when we say, so what happens with the step which was about the constructor of the client making a connection to the server with the help of the constructor of socket? What we had achieved was creation of connected streams. There was a stream, input stream and output stream on client side. There was an input stream and output stream on the server side, which were getting created as part of a socket, and these are cross connected. This is similar to what we also have on phone, right. What you speak on your speaker is available for listening on the receiver at the other end, and whatever he puts on the speaker of the other side is available for listening on the client side. So, yes, this is how networking is easily achieved in Java. So, we can say, okay, to achieve networking, as far as steps are concerned, 3 steps are sufficient to achieve the connection part. Okay. Just to have connection part, that is, yes. What are those steps? Let us repeat it. We have first step, we have the first 2 steps which would normally be done on the server side. First step was to have to create an object of server socket. What it does? It reserves a port and starts listening, and it reserves a port for itself. Fine. The server wants to listen on a particular port, start listen for connection. And second step which is done is to listen for, to actually start listening for some in order to service some in order to, so the second step is basically to call the accept method on this object of server socket. Fine. So, this is what we do on the server side. The second method was a blocking method. So, it is getting blocked, whereas on the client side, the client simply makes a connection to the server by calling the constructor. Fine. And so, the 3 steps, 2 on the server side and 1 on the client side, this is sufficient to make a connection. Once the connection is done, then the next steps would be about making communication. Fine. Connection is established, communication is now possible because of the streams. Fine. Okay, so we normally know how to handle streams in Java, right? Fine. We have input streams and the output stream. So we know how to handle input stream and output stream. So if you have a input stream, we can use it for reading the data which comes from. So in this case, the data is coming not from a file. So it's not an input stream which reads from a file or it reads from a keyboard or something. That's an input stream which reads from the network, which reads from the TCP connection. Same way, we have an output stream which writes to the network, which writes to the TCP connection on the network. Fine. So that's how we achieve initial connection between two processes in Java. Fine. Then it's up to us how we use these streams. We decide some protocol for communication between to use these streams. Fine. Okay. So yeah, we could take an example where we can demonstrate how to how does a client and a server process work. Okay. Normally, what will be needed here is on the server side, what will be needed? It's not sufficient just to be able to accept one connection and then start servicing the connection. What is needed on the server side will be more than just handling the connection here. Because yes, we'll be having, it's not about server being able to handle just one connection. It also needs to be handling multiple connections. That will require multi-threading. At this moment, we are not going to talk on the multi-threaded aspect. Okay, fine. We'll not use multi-threading, but just a very simple server and to give some kind of a service to any client who makes a connection. So in Java, let's try to write a small application. Let's look at demonstration of a small application which would first start listening on a port, which we can decide. We can have it parameterized on which port it should start listening. Okay. Then once it starts listening, whenever a client connects, what the server side should do? It should wait for a client. Whenever a client connects, what the server should do? So let's have some task for the server side. So let's do a small service which is nothing but a very simple thing. We don't want to do some kind of rules like HTTP or some other thing. We don't want to go into a complex application layer. So as a demo, we can have something like, okay, the server can simply wait for anything to come from the client, and whatever comes from the client, let the server send the same thing back to him. So let's call this class as a echo server. So let's see how we can create an echo server. So what do we need to create an echo server? Okay. So yeah, we'll have a class. Okay. And so let's write a small class here. Okay. So how do we go about writing this class? Yeah. Okay. So for this, yes, we have a class here. This class, let's put some instance variables. What will it require? What will the server require? The server will need, in order to reserve a port for itself, what does it need? It needs a server socket object. So we keep an instance variable for the server socket here. Okay. Next, it will be accepting on this server socket, it will be accepting a connection, and therefore what do we have? Once a connection is accepted, once a accept connection method is successful, what do we get? We get an object of socket. Fine. So we keep another instance variable where we can keep the socket, which we get with the help of accept method. And then what is the important part in the socket object which will be useful for us for the communication purpose? We'll have the input stream and the output stream. So let's have our class called echo server having these 4 instance variables. We have our server socket object, we have our socket object, we have the input stream, and we have the output stream. Fine. Now let's develop further. So let's write our constructor for the server socket. Okay. So yeah, since here we would like to parameterize about how on which port the client would make a connection, on what port the server would start listening. Okay. So we have our constructor for echo server taking one parameter here, which is for the port number on which it should listen. Now another important thing which is related to the API for networking. Okay. One thing I had forgotten earlier was all this is part of the java.net package, and therefore we also have this import for java.net.star here. Okay. So fine. Okay, so that's one thing. We have another important thing, the constructors of socket, the server socket, the accept method. Okay, most of the methods here, okay, in the socket class, server socket class, okay, whenever they fail, they throw some subclass of IO exception. So all these methods have a throws for IO exception. Fine. So fine. So as we proceed with our constructor here, in the constructor of servers, in the constructor of echo server, fine, we are taking parameter as port number, and we have a throws here. Fine. So if he is given a port number which can't be reserved for any reason, if it fails, yes, we would like to throw the we don't want to create a echo server in that case, right? So we have our throws IO exception here, and then yes, what do we do here when someone says, okay, I want to create a echo server? So fine, for that what we should do is, we'll just in this constructor we simply would like to reserve a port for ourselves, and that's done by calling the constructor of server socket, and that's where we initialize our variable, fine, for server socket, and assign it to a new server socket with the specified port number. Fine, that's it for the server socket part. Now proceeding further, yeah, what else do we want to provide? Okay. After having reserved the port, we would like to start listening for connections. Okay. So waiting for the client to connect. Okay. So let's have a method here. Let's provide a method in echo server called get a connection. Okay. Fine. Get a connection without any parameters, because we already have the port here, port number already known to us. So we have get a connection, no parameters needed. Okay. And returns void. It's just simply its simple job is to block, wait for a client to connect. Fine. So this also will have a throws IO exception here, and then what we want to have, what are the steps now? Oh, we'll just now call the accept method to get blocked. Fine. So blocking for some client to connect. Fine. So we have the accept method here, and then after accept method, once the client connects, what do we do? Take out the two important things, that's the input stream, output stream. So our server, our socket class, fine, provides methods for getting the input stream and output stream to us. So here we are going to use this method called get input stream, which returns the object of input stream, which is the one which is connected for reading what is provided from the other side. Fine. So we have this method called get input stream, which we use here. So on this object of socket, which we got with the accept method, we'll call the method get input stream and assign it to the input stream. Fine. This variable called receiver, which we have here. Okay. And then the next step, we similarly we also would like to use a store the value, store the output stream object. So we have our transmitter here, the variable called transmitter, which is for the output stream, and here we have this method called get. We use this method called get output stream. Fine. So get a connection method has just 3 steps in it: accept to get a connection, then we have the get input stream to extract the input stream from this accepted connection, then we have the get output stream to extract the output stream from the socket. Fine. So that's the step for the get a connection. So with this, yes, the connection, we can get a connection, we got the input stream, output stream. But then the another important part would be giving the service on the connection, right? So for giving connection, a service on the connection, okay, let's add a method. Fine. Let's call the method as service connection. So how do we service the connection? Oh, in this, when we are servicing the connection, we are only going to be dealing with the input stream and output stream only. Oh, we just want to listen to what is sent from the client and send it back to him. So yes, how do we go about it? The steps here. Yes, first step, we'll have, okay, So we create what? Read the first byte. Yeah, we need to read the bytes till we get a -1, right? End of file. The end of file on a read of a input stream which is from a socket indicates that the client on the other side has closed the connection. Fine. So whenever the other side closes connection, you will get a -1 on the read method. So here's first step. Yes, we'll first say, okay, let's just read read 1 byte from it. Fine. Assign it to some variable. Let's call it A. Fine. And then what do we do? We'll have a while loop waiting till. So we keep on reading and sending it back to the client till we get a close connection. So we'll have a while, fine, A, which we have read here, is not equal to -1. While A not equal to -1, yes, what do? We got a byte from the client. So what do we do with this byte? Okay, we would like to send it back to him. Okay, but before that, let's introduce one more thing. Let's see what is coming from the client for our purpose, right? So we can see on the server side what the client is doing. Simply silently sending it back? No, instead of silently sending it back, let's put one statement. Fine. So we'll have the system.out.println. We'll need to cast it into character and print the value of A, the variable with where we are receiving the value. Fine. Okay. So that's so in the while loop, yes, we are first showing it locally on the server side what we have received from the client. Next step, yes, what's the next step? We'll have a send it back. How do we send it back? For this, yes, we'll use the transmitter, the output stream which we have from the socket. Fine. On this transmitter, we use the write method, write it back, and then again read the next byte. Fine. Write it back and read the next byte, and again go back into the while loop, checking till we get the -1. Fine. So that completes our loop for the while loop for giving transmitting back everything which comes to us. Fine. And it's a client who will then close. So whenever till the client has closed connection, we just keep on doing this. Once the client has closed the connection, what we need to do here? Oh, we need to be. Oh, here also we need to close our connection. Fine, we can also indicate close of connection. So for closing our connection, yes, one simple thing would be we always have those input stream and output stream which are from the socket. You can close them, but we also have a close method available on the socket class. Calling close on the socket would also close the input stream and output stream available on the socket. So we can simply call close on the socket object. Fine. And once this is done, yes, so that finishes our service method. Okay. Once we have these 3 methods ready for us, now we can easily write a main method where we can use these things. So yes, what goes in the main method? Okay, so we can go for public static void main. We can take as command line argument the parameter for the port number on which the user here intends to start the echo server service, right? So he can start echo server and specify the command line argument. So for that, yes, we have a variable to take the command line argument here. Fine. Convert it into an int. Port number is going to be an int. So we have the parseInt method, and then next, we would like to service multiple connections. Of course, not simultaneously, one by one, but we can have a while true loop. So I'll service one client. Once I have serviced the first client, I can keep on servicing the second and the third and fourth, so on. So our step was we got the port number. Now we convert to int using the parseInt method, and now we create the object of echo server using this port number. Fine. That's our step 1, and then have a while true loop. In this while true loop, we'll have on this server, on this echo server object, we'll be calling the get a connection. It has to first wait for a connection, and once the connection is got, we'll service the connection, and that's it. That's a while loop. That's it. Fine. So yes, by this, yes, we have created a server side for our Java application. At this moment, we'll not write a client side of the application. Fine. as a client, we have lot of general purpose TCP client which are available. So yes, to test our server, you can always use some application like telnet, which is available, where you just specify the host and port. You can try it out, make a connection. So on one machine, compile this code, run it, and then from another machine you can just make a connection using telnet, utility like telnet, and then yes, then you can try out, you send something, okay, or here we are sending this and we see an output. Oh, what is coming back to the client side is it's repeating, fine, whatever you had sent, it's the same. So if I say hello here, oh, I get back hello, oh, and oh, I also see hello on the server side. Server side was echoing, right, using the system.out, and then it sent it back. So I have the things, whatever I keyed it, I am receiving it back here on the client side, whereas on the server side, I am seeing whatever the client had said. Fine. So yeah, this is a simple application, eco-server application, which is used here to demonstrate how we can achieve networking in Java in such a simple few steps only. Fine. So fine, we'll see further later on.